In this example, we have 4 charges, same number, all of them are positive, 100 microcoulomb each, and they are separated by 1 meter from each other. As you see here, we have square arrangement. I want to show you how to find out the force on Q4 due to the presence of Q1, Q2, and Q3. Let's see. First of all, I'm going to find out the force on Q4 due to the presence of Q2. Since they are like charges, they're going to repel each other. So we have F24 like this. Then I'm going to find out the force on Q4 due to the presence of Q3. It's going to be like that. So Q3, F34, electrical force. And finally the last one, these two, it's going to be something like that, F14. It's going to be force on Q4 due to the presence of Q1. So let's find out each of them. So we have F24, K, Q1, Q4, sorry, Q2, Q4 divided by R squared. That's the distance, which is 1 meter. So it's going to be, K is Coulomb's constant, which is 8.99 times 10 to the power of 9. Q2 is 100 micrometer, so 100 times 10 to the power of negative 6, because we want to convert microcoulomb to coulomb. And Q4 is 100 microcoulomb, so 100 times 10 to the power of negative 6 divided by 1. So that will be 89.9 Newton. Now let's find out, and that's gonna be on X direction. Now F34, based on what you see here, it's going to be exactly the same thing. The magnitude is going to be the same thing, but the direction is going to be toward Y direction, to south. So since the Q's are the same, the distance are the same, K constant is the same, so I don't need to calculate it. So it's going to be 89.9 in the Y axis. Y direction, south. And then we have F14 K times Q1 times Q4 divided by R squared. So it's going to be 8.99 times 10 to the power of 9. Q1 is 100 times 10 to the power of negative 6. 100 times 10 to the power of negative 6. R squared, the distance in here. If I use Pythagorean theorem, this one is 1, this one is 1. So the distance here is going to be square root of 2. So R squared is going to be square root of 2 to the power of 2, which is going to be just 2. So the force is going to be half of the other forces. So it's going to be 44.95. Now I need to decompose this one into X and Y direction. But in order to decompose it, I need to know the theta. So I need to find out F14X and F14Y. F14X is going to be F14 cosine theta, and the other one is going to be F14 sine theta. What is theta? Theta is going to be the same as this guy. As you see here, the opposite and adjacent, both of them are 1. So sine or tan, I can say tan. We can use sine law or we can use tan. Tan theta equal to opposite divided by adjacent, which is 1 divided by 1, and that's going to be 1. So tan theta is 1, and we know tan of 45 is 1. So theta is 45. So we have F14 cosine 45, F14 cosine 45. So we already found F14 magnitude, so it's going to be 44.95 times cosine 45, 31.78 Newton. Sine 45 and cosine 45 are exactly the same thing, so that's going to be the same number. So I can say f of x is going to be f24 plus f14x, so that's going to be 89.9 plus 31.78. And I can do the same thing for y direction, 89.9 plus 31.78. That's going to be 121.68 Newton. So F net will be fx squared plus fy squared. It's going to be 121.68 squared plus 121.68 squared. It's going to give me 172 Newton. And that's the final answer.